How do you realize value from simulation-driven design? Let's talk about the 4 strategies you can use to do exactly that. Okay, so let's talk about the different approaches that your company can take to realize the value out of simulation-driven design. And just as a quick bit of context, let's talk about what simulation-driven design is real quick. So basically, it is using analyses and simulation results to help people make design decisions when they're developing new products, right? So is this concept better than this one? How thick should this rib be? All sorts of decisions like that. So the first approach is an analyst-led manual approach. And let's take a quick look at what that looks like. The idea here is that an engineer will work with an analyst to figure out what options they want to look at. And the analyst here is really responsible for setting up and running the analyses. This is done through an expert analyst toolset. So these are typically pre-processors, post-processors, and solvers. And there's a wide array of these technologies that are available. A lot of times you see these analyses run on networked drives, which you can see there at the top in white. Typically not as much on cloud-based solutions or on desktop local solutions. And the idea here is that you explore one option, you run an analysis, explore another option, run a different analysis, maybe explore a third one, and you compare the results. Which one was stiffer? Which one had a lower stress? And all of those other measures that you might want to be interested in. So this is, ideally, this is a very good approach. You have the person with all the expertise running the analyses. You have the person that is responsible for making the design decision, involved in kind of driving what approaches or options should be considered. A shortcoming here is the availability of analysts' time during the development cycle. They usually have a full plate working on verification and validation simulations, right? So they're often handed off a design. Okay, make sure this actually works before we build it and prototype it. So spend hard money actually building that. So there's a challenge there. A lot of times this approach is used when you're looking at parts and systems and assemblies that are high impact or long lead time, right? So when you're looking at a chassis for a car. But you don't see this used for moderate important parts and lower, right? Because there's just not enough bandwidth to kind of consider that. So this is one option that you can take into account. Another option is this engineer hybrid CAD CAE, computer aided engineering simulation approach. And the idea here is the engineer is working on their own. They're working independent of the analyst. They're running their own simulations in the midst of the different design options and concepts that they're considering. Now, they use a very different tool set here for this. This is where you see different applications that are this mix of 3D modeling and geometry modeling, as well as simulation and analysis capabilities. Direct modeling is a very important capability here as you push and pull and explore different options. A lot of times you see these applications running on local desktops that might be sitting underneath your desk, but also they run in the cloud a lot as well, and run through a browser or a connected application. The shared drives are not, or networked computers in an internal network. That approach is not used as frequently. So, the same sort of thing here. You're looking at multiple options. You want to understand what the results are so you can compare and contrast this. So this approach is the one that's been used for, 2 decades now, at least 15 years. And this concept of putting simple tools in the hands of engineers early in the development cycle, has been around for a long time. And it has been successful to moderate levels, right? So we're not seeing a lot of engineers. We're not seeing every engineer out there using this approach today. It just, the findings from studies, ones we have conducted, just don't support the idea that, hey, this is widespread. This is the mainstream use for everybody that is out there. So this is why some other approaches have kind of emerged. And let's talk about that next. The third option that we've seen out there is this engineer automated simulation. And again, this is where an engineer is working on their own, independent of any analyst. The idea here, however, is that there's been an automated simulation workflow that's been developed and designed by an analyst, an expert analyst who has the expertise to develop these things, right? So there are standard inputs for these in terms of different, not only the model geometry, but also things like, well, where is this held? Where is the load applied? So you designate certain geometric parts or places where that's going to be used. Now, this setup is commonly run on networked computers, so you can leverage high performance compute clusters and things like that. It is also run in the cloud. And the same type of thing happens here. You look at a number of different options. So this is an option that's emerged in the last, I would say the last 5 years to a greater degree. They've been around a little bit longer than that. We can go back, for a decade, maybe 15 years. That this type of technology has been around. But this concept of, hey, we're going to develop a application-specific workflow or automation. And when I say application-specific, it's looking at, okay, NVH in the interior of a car, fluid flow cooling for electronics. And the scenarios, the workflows that you set up for those really aren't applicable anywhere else. You can't take the cooling analysis and apply it somewhere else. There are certain inputs. It's designed to have a certain output. And these get really, really specific because the solver matters, the mesh density matters, and that's the stuff the expert analyst is kind of setting up this workflow to apply to. So this works if you have very specific scenarios, if you want to enable your engineers to look at a lot of different options. So that's the application there. Let's look at the fourth one, the last one. Now, in this case, we're actually looking at an analyst using the same type of technology, but being involved earlier on. So again, like the very first approach, you have an engineer working with an analyst, but the analyst is kind of like the enabling role in this case. They're the ones running the analyses. But instead of using the traditional kind of manual preprocessor, post-processor solver, instead they're using the same type of automated workflow, but for a very different purpose. The idea here is that we're expanding the bandwidth and capability and throughput of the analyst so that they can afford to be involved earlier in the design process, earlier in the development process, right? So it's not, okay, I'm going to set up this analysis now and see what the results are. It's, okay, I'm feeding this engine that's going to run and execute these simulations, and look at the results. Again, these run on networked computers, HPC clusters, cloud-enabled solution sets. And again, we're looking at a number of different options, and the automation certainly helps generate those and helps them look at results. So this is actually a very viable option. You know, people have long discarded the concept of analysts being involved early in the development and the design process, just because there's not enough of them. And for the analysts that you do have in your organization, they are super busy. They have deep queues of work that they need to address first. Very high priority work. So in this case, we're expanding their bandwidth and making them available earlier in the design process, which makes this whole thing, feasible. So again, there are 4 scenarios that we talked about today. We talked about analyst-led manual types of approaches. They often don't have enough time available to get that done. We talked about engineers working independently with hybrid CAD CAE simulation solutions. We talked about engineers using the simulation workflow tools that are application specific, really aren't generalist type of solutions, very specific to specific scenarios. And then finally, we talked about analysts getting involved earlier in the development process with these same type of workflows. So those are the 4 approaches that you can use to implement simulation-driven design and realize the associated value. That's it. Take care and talk soon.